Hello, today we're doing a example of the use of chain rule when you're so let's say we're giving a function y, which is x squared plus 3x plus 6, where all this is being squared. So now the thing is, well, chain rule is how do I know when to use it? So most times we like to say we have a outside function and a inside function. And that can involve trig functions because you always have sign of something, which is an inside of it, but when you're substituting inside. But first, let's distinguish the things here that we need to have when we're dealing with chain rule. So we're going to use two different colors here. So whenever you hear the term chain rule, I want you to always think about that you have a inside function and a outside function. So here we're going to let's let lowercase f of x represent the outside function. And we're going to try to connect these little ideas here. And then we'll say we'll let g of x, oopsie. And we'll let g of x represent the inside function. So now you may be wondering, this may be a familiar term when before in time we were learning how to do functions such as what we call. So the idea of chain rule, it really originates from composite functions. A composite function is basically a function where you can have multiple functions, but we're usually, when we're doing examples of composite functions, usually you're substituting one function inside of another function. And this is a way to kind of grasp the idea of chain rule. So essentially a composite function is like saying you have a f function, but you're substituting in another function inside that f. This is how I want you to first kind of get the idea regarding chain rule. It really originates from the idea of being a composite function. So, and when you have to think about this in terms of when you're giving functions, what you kind of have to do is kind of go a little, but I want you to notice what I like to do is what is usually inside. I like to think about that as the inside part. This is what was plugged into the function before in time. So usually when chain rule, you always have to first identify what's my outside function and what's my inside function. So if I want to do that, so now what I want you to think, this whole thing is being squared, right? Inside of this y. So before in time, because remember, f of x is going to be our outside function. So before in time, this function was actually just a function with x being squared. Because if you think about it, is you're substituting, when you substitute g in, you're just substituting whatever g, wherever you see an x, you're putting the g function at. So if that's the outside function, then the then our inside function, which is we're using for blue, must be what we're substituting into the other f function. Because you notice if I substitute these two things in, we actually get the function we have, because you're plugging in G into F to get what they have here. So this is how we first think about it, as it's a composite function. So this is what I want you to first kind of take when you're approaching chain rule. You always identify, because sometimes you can have more than two functions. You can have three, so we use the letter H. But in this scenario, we only have two functions in this case. So essentially, what I want to say is that f of x squared plus 3x plus 6 is actually this function here, if we look at it. So now you should see that the G is the inside part and the F is what's outside. But usually when you have something being squared in parentheses, if it's a polynomial or other things happening there, usually the outside is basically just the variable and whatever power it's raised to in this scenario. That's the little takeaway. Now we say, well, what's the definition of chain rule? So chain rule, when you have only two functions, what it says to do is, when you have this type of composite function, it says you take the derivative of the outside part, but whatever is inside this function here, but we're using g of x now here, that'll play a role. So what it's saying is you take the derivative of the outside part, but you're still, and what happens is you substitute your g function into that outside derivative. So that's the first part. And I should use a different color to distinguish the two. And then it goes on to say you multiply this part by the derivative of your inside function. Okay. This is the definition of chain rule regarding two functions. So now that I have this, now what we need to do essentially is to say, well, what's f prime of x? What's g prime of x? So we need to find these guys somehow. So first, let's find f prime of x first in general. We have that f of x, right? It's just x squared. So if we take the derivative and using power rule, we should just get 2x. Okay. Now what I want you to pay close attention to is, this is just if it was an x here. But I want you to notice in our problem, in the actual formula for chain rule, the g of x is actually replacing the x. So all that means is, wherever you see x, so then we can find what's f prime of g of x. See, it's working like a composite function. But instead, it's like you're taking the derivative of your original, your function that you're plugging g into. That's the first part of chain rule. The idea to have. So I'm replacing I'm just taking a little step by step here. So now I want to know what's f prime of g of x. And then all you say to yourself, well, first you need to say, what is g of x? G of x is our inside part. It's what's in blue here. That's your g of x. So then what this essentially says is that f prime of g of x, this thing, is equal to, Well, first we say, well, what's f prime of g of x? Sorry. So, well, we have that g of x is x squared plus 3x plus 6. And all this says is in your derivative of the f, wherever you see an x, you're going to substitute x squared plus 3x plus 6. So essentially, your f prime of g of x is actually going to be 2 times, because remember there's a 2 here, but the x, there's only one x, so I'm substituting x squared just trying to use different colors so you can still kind of first get in the habit of just saying, well, what's my inside part? So what you have found at the moment is the first part of the chain rule, which is this key guy. This is what we found so far. F prime of g of x is actually 2 times x squared plus 3x plus 6. And notice there's only one little last key to find here, which is g prime of x. So first you identify what's g of x. And we have g of x is x squared plus 3x plus 6. Hence, and let's kind of draw a squiggly line, separate these little things here. So g prime of x represents the derivative of your inside function. So the derivative of x squared, so we do these one by one as we go down. So this is 2x. And then derivative of x is just 1 for the 3 here. So this becomes 3. And always remember the derivative of a constant is always 0. So hence, g prime of x must be 2x plus 3. So what we have here, the two important keys we're putting in yellow are these guys. So now we have that, because we're trying to find y prime. So you're trying to find the first derivative of this. That was the goal. But in order to differentiate this, we had to use chain rule, because you have two functions in disguise here. So what we have found is that, so we found out that f prime of g of x is equal to, oops, I made two separate pages there, is actually 2 times x squared plus 3x plus 6. And we also found out that our derivative of the inside function is actually, just to point it here for you, the derivative of the inside part was 2x plus 3. So essentially, so then y prime, using the definition of chain rule, so it's f prime, so it's the derivative of your outside function with the inside function being plugged into it afterwards. That's the way I like to say this part. multiplied by the derivative of the inside function. And the inside function is represented as g prime of x. So now the last thing to do then to say is, well, the derivative of our y function, the first derivative will be 2 times, let me use a different color, even though I didn't use it there, 2 times x squared plus 3x plus 6 multiplied by the derivative of your inside function, which is just 2x plus 3, and you're done. This represents the derivative of our function. And you could go to distribute to simplify more, but this would be an acceptable answer. So just let's do a little recap. So in return, we had x squared. So we'll do a quick summary here. So we had x squared plus 3x plus 6. All of this being raised to the second power. So chain rule, essentially you have an outside function, which we call f, and an inside function we like to call g. But this all comes into the idea of a composite function. So you kind of have to go back in time a little and say, well, what was here before it was this? So I saw that the parentheses is being squared. So this had to be a formula of being x squared. Because if the whole inside part is here, we're substituting, because we will see that if you substitute x squared plus 3x plus 6, you will get the whole thing here. So then once you can identify your outside function, you identify the inside part. The outside one is the one that's a little tricky, but the inside is usually means it's just inside. And if you want to think about outside, the whole thing is being squared. So it's outside the parentheses in a way, the parentheses outside. And once you can identify your outside and your inside function, you find the derivative of your outside function first. And then you substitute, because from chain rule, it's the derivative of the outside function. That's what this part is saying. F prime represents the derivative of the outside function. But you're substituting the inside function into this derivative of your outside function. So that's why we come to this step here. So then I substitute the inside function into the outside derivative. And that represents the first part of your chain rule. And the last part that is tagged along on the chain rule is your derivative of the inside function, because you identify what's the inside function, which is here. And then you take the derivative of your inside function, which is the portion that's highlighted in yellow. And once you can find this, you multiply both of the pieces together, and that gives you the derivative of your function. If you're asked, because they can say find y prime, they can say differentiate the function. They won't say to use chain rule. This is just something you get into a habit of as you practice more examples, saying, well, I do have a outside and inside function. And you have been using chain rule. Let's say also, like if you just had x squared, this is actually chain rule, because if you want to imagine, this is like a parentheses with x, where x is the inside function. So essentially what happened is they took the derivative 2, but your inside function is x, but multiplied by the derivative of the inside. This is just shortcutting here. Derivative of x is just 1, but that's the reason why you just find that's 2x. But they don't show that, but you have been using chain rule when you first start building derivatives, but they don't really show that case, because the derivative of the inside is always 1 here, so it doesn't really matter to use chain rule. But in a scenario you see here, the derivative of your inside function is not 1, so you have to be kind of careful here. But this is the general way on how to, just the example involving chain rule, because there's multiple examples you can create, because you use it in trig, you use it in polynomials, you use it in logarithms. It's everywhere. But most times you use it. So the way I like to think about it is we use kind of chain rule. If you know that the derivative of the inside part will not give you 1, then you have to kind of go through this process to see what's that derivative of the inside piece and find the derivative of what's outside. And I hope this can help with chain rule, and you can always leave a comment if you ever have any questions. But the main idea here is that the equation that you want to have in your notes is this equation. And then having to know how to distinguish these two. So that's the main goal you want to have. And again, I hope this helped, and I hope you have a wonderful day, and always keep practicing. Practice makes perfect.